Hi students, today's topic is cell. What is a cell? And that I am going to explain. You know already about the cell and battery. It can produce the electrical energy, right? And how to define the cell? Cell is a device which converts chemical energy into electrical energy. Cell is a device which converts what? Chemical energy into electrical energy. Electrical energy is called as cell. Now the symbol of cell. What is the symbol? Okay, how it is denoted? Right, this is the symbol of the cell. Cell has two terminals, positive and negative. And the next one is what is battery? Right, battery is the combination of cells. Battery is the combination of cells. Okay, the combination of cells is said to be battery. The battery symbol will be like this there. This is the symbol of the battery. We can connect the several cells in the series like this. And this is said to be battery. Okay, this is symbol of battery. And now what is EMF? Okay, some basic terms I am going to tell about the cells. What is EMF? Electromotive force. What is electromotive force? What this cell will do in the circuit? What is the need of the cell? Cell converts chemical energy into electrical energy. It supplies the current, right? And it is used to maintain the current in the circuit. And electromotive force, that means the battery or the cell is doing some work to flow the charge through the circuit. Now that is the work done is said to be EMF. EMF is also equal to potential difference. The definition of the EMF is the work done to move unit positive charge through the circuit is called as electromotive force. Electromotive force. What is electromotive force? It is the work done to move unit positive charge through the circuit. It is the work done to move unit positive charge through the circuit is called as through the closed circuit. Here we have tried it as closed circuit. And look at here, we will take this its definition one more also there, that is the potential difference. Actually EMF is also equal to potential difference. The potential difference across the cell or battery in open circuit. Across the cell in open circuit is called as EMF of cell. EMF of cell. That means EMF is equal to, okay, it is denoted with E, just like this. Okay, but actually E we wrote electric field intensity. You must remember this is the epsilon, just like epsilon we will write. Okay, and this is the symbol of EMF, we will write it here. Okay, symbol of EMF. And look at here, EMF we will write like this symbol. This EMF is equal to what? Potential difference across cell, right? Across cell, but it is in open circuit. What is open circuit? I will tell. EMF is equal to potential difference in open circuit. What is the SI unit of EMF? SI unit of EMF is volt. Okay, it is similar to voltage or potential difference unit. Okay, the SI unit of EMF is volts. SI unit of EMF is volt. Okay, symbol capital V. And now if you take the what is actually EMF and what is cell, what is this? For example, this is a closed circuit. Okay, this is a closed circuit, and this circuit has some external resistance capital R. Okay, this is the external resistance, and this cell has some EMF, and so this some current will passes it here like this. To maintain the current in the circuit, this cell is required, and what this cell will do, it supplies the electrons, right? And now it will create the potential difference. EMF is equal to potential difference, and due to that potential difference, what happens? Electrons will passes. Electrons passes from negative terminal of battery to positive terminal of battery. Okay, that means the battery or the cell is doing some work on the electrons or the charge to move in the circuit. The amount of work done to move unit positive charge, like this negative charge is going, means the positive charge will goes like this, because the direction of the motion of positive charge is opposed to the direction of motion of electrons, negative charge. When the negative charge is going this side, means indirectly the positive charge is going this side. Okay, then the amount of work done to move unit positive charge or the unit positive charge through the closed circuit is called as EMF. The battery is doing some work to move the charge through the circuit. That work done is called as EMF. EMF is nothing but potential difference. Potential difference is nothing but work by charge. Means EMF we can write as work done to move unit positive charge. Work done by whom? Work done by the cell. Work done by the cell to move unit positive charge through the circuit is called as EMF of cell. Okay, right. And now this is the EMF. Next, for example, if you take the torchlight cell, okay, you have the small cell or wall clock cell. Okay, wall clock cell if you will take, on that it is written, it is there 1.5 volt. This is the potential difference. Potential difference or the EMF. Okay, potential difference or EMF is 1.5 volts. Okay, and the next one is terminal voltage. What is terminal voltage? And before going to terminal voltage, I will tell about the internal resistance of cell. Internal resistance of cell. Every cell has some resistance also. Okay. Resistance means what? Opposition for the flow of current or flow of electrons. Internal resistance of cell denoted with small r. What is internal resistance? The resistance offered by the, okay, in cell construction in the lower classes, you know, the cell has two electrodes along with some electrolyte. Electrolyte means some solution. The resistance offered by the electrolyte is what? Okay, if you go for the construction of the cell has one anode plate and other one is cathode plate, two electrodes. Along with that some solution will be there. This will act as, one is act as positive and other will act as negative terminal, and this is the battery or the cell. Okay, this cell, when the current passes, this electrolyte also opposes the flow of current. Then the resistance offered by the electrolyte of cell, the resistance offered by the electrolyte of cell is called as internal resistance of cell. Okay, it is called as internal. Cell inside also some resistance is there. Cell also cell only supplies the current, and cell also opposes the some flow of current, right? The resistance offered by the electrolyte of cell is called as internal resistance of cell. This is the internal resistance of cell. Okay, and this is the internal resistance of cell. And now, on what factors the internal resistance of the cell depends. Okay, this is for example cell. Inside the cell only this EMF is E. EMF, okay, you have to denote like this. So many confusions are there in the letters, and remember this is the EMF. Okay, you have to write like this, and this is the EMF, just like epsilon only. Okay, just like epsilon only. And now capital E is the electric field intensity, and this is EMF. That also we can read either E or capital E we write. Okay, we can read it as E. Okay, EMF is E, and it has some internal resistance. This resistance is inside the cell. Okay, this is small r is here, internal resistance of cell. Internal resistance of cell. Internal resistance of cell. Okay, and on what factors the internal resistance of cell depends. For example, this is one cell I am going to tell. Okay, this is one positive terminal of the cell, and this is the negative terminal of the cell, and there is some solution is there, and this is the electrolyte, right? Electrolyte. And now the resistance offered by the electrolyte for the flow of this is cell. Okay, resistance offered by the electrolyte of cell, okay, that is called as internal resistance. And now on what factors the internal resistance depends. Factors on which the resistance depends. Factors on which internal resistance depends. Internal resistance of a cell depends. On what factors the internal resistance of cell depends. Okay, that I am going to tell. The first point is that the internal resistance is depends upon nature of electrolyte. Nature of electrolyte. And the second point is that there are so many points are there. I will rub and I will give. Okay, you can take the screenshot and note the points. I am going to continue the class. On what factors the internal resistance of cell depends. The second point I am going to tell, the internal resistance of cell is directly proportional to the distance between electrodes. Okay, internal resistance is directly proportional to distance between electrodes. This is D. Internal resistance is smaller, proportional to D. If the distance between the electrodes is more, then internal resistance is also more. The second point is internal resistance of cell. Internal resistance of cell is directly proportional to the concentration of electrolyte. Electrolyte is the solution. Okay, concentration of electrolyte. Okay, are proportional to concentration. And next, internal resistance, this is the first point, this is the second point, third point, this is the fourth point. Internal resistance is inversely proportional to the common area of electrodes. Okay, electrodes has some surface area like this. This is the one electrode, this is another electrode, right? This electrode has some area, right? The common area we have to take, the lowest area we have to take. Okay, and now internal resistance depends upon the inversely proportional to common area. And the next fifth point is that internal resistance means resistance offered by the cell. Cell resistance is the internal resistance of cell. Cell inside some resistance is there. Cell also opposes the flow of current, right? That is internal resistance. Internal resistance of cell depends upon temperature also. Internal resistance of cell depends upon temperature, right? And now this one, internal resistance of cell decreases with increase in temperature. How it will depends? Okay, that means if temperature increases, okay, temperature increases means internal resistance decreases. If temperature decreases, then internal resistance increases. This is the factors on which the internal resistance of a cell depends. There are different types of cells are there, Leclanche cell, Daniell cell, okay, dry cells are there. There the chemical energy convert into electrical energy. Let us continue. The next topic is the terminal voltage. Till now what we discussed? What is EMF? Okay, what is internal resistance? That we discussed. And the next one is, what is terminal voltage? Now I am going to tell about the terminal voltage. What is the terminal voltage? If you go for the cell has two terminals. What are they? Positive and negative. And what is the terminal voltage? Let us see. Now the next topic is terminal voltage. This is V. Voltage or potential difference are same. The terminal voltage or the potential difference is same. Voltage or potential difference both are same. Okay, that is the definition of the terminal voltage is the potential difference across the cell. The potential difference across two terminals of cell. Okay, cell has two terminals. The potential difference, there is some potential difference. Cell produce the potential difference. The potential difference across the two terminals of cell. The potential difference across two terminals of cell is called as terminal voltage. Terminal voltage is nothing but potential difference across two terminals of cell. For example, let us see here one diagram we will give. This is one cell, okay, and this has some EMF E and it has some internal resistance small r, right? And for example, this is open circuit. We are not connecting to any external resistance. This is not closed circuit. It is an open circuit, right? In case of open circuit, what happens to the terminal voltage? Terminal voltage means potential difference across two terminals of cell. Okay, the potential difference between these 2 points, potential difference across these 2 points. And for that, what is the potential difference in open circuit? The potential difference or the terminal voltage, right? Terminal voltage is nothing but potential difference, but terminal voltage is equal to potential difference. Terminal voltage is equal to potential difference, but the potential difference across the cell in open circuit is called as EMF. That means in this case, potential difference is equal to EMF. Potential difference is equal to EMF. EMF, remember that we have to denote it with epsilon like this. Actually this also we can read as E, okay, but we have to write like this. Why we write like this? Why we cannot write like EMF, E, capital E? So in some books in capital E it is denoted with capital E also, but capital E means electric field intensity. That's why I am denoting with like this, right? E, or it is just like similar to the epsilon. And now V is equal to terminal voltage in the open circuit. Okay, what you will get? Terminal voltage in the open circuit. V is equal to, we will get as EMF, right? EMF, that is equal to epsilon, right? Now if you take the closed circuit, what happens? What is the terminal voltage in the closed circuit? Let us see the closed circuit. In the closed circuit, what happens? Let us draw the diagram for the closed circuit. And this is a cell, its EMF is epsilon and internal resistance is small r. It is connected to some external resistance. That external resistance is capital R, right? And now some current passes at here. Now this is the closed circuit, okay? And now in this case, potential difference across the two terminals of cell, this potential difference, right? What is the potential difference across the two terminals of cell? This is one terminal, this is another terminal, okay? This battery has two terminals, this is the one terminal and this is another terminal. Potential difference across the two terminals of cell is called as terminal voltage. Now what is the terminal voltage in the closed circuit? Okay, now let us see in closed circuit, what happens to the terminal voltage? In closed circuit, the terminal voltage V is equal to potential difference. Terminal voltage is nothing but potential difference. Potential difference across the cell. Actually this internal resistance is inside the cell. I drawn this smaller as outside, but this is inside the cell, okay? But inside the cell it is difficult to represent. That's why I wrote it here. This small r is the internal resistance of the cell. This is internal, means inside the cell it is there, okay? And potential difference across the cell I want, okay? That how to find out the potential difference? According to Ohm's law, we write potential difference as V is equal to IR. Very simple. And we can also write terminal voltage, one more formula also we write. Terminal voltage V is equal to, we write as E minus IR, okay? E minus IR. There are two formulas are there. What is IR in this? IR is said to be last voltage we write, okay? Last voltage, where it is last, okay? Actually due to internal resistance, actually in the open circuit potential difference equal to EMF, but due to internal resistance some potential difference drop will occurs, okay? The drop of potential difference due to internal resistance. What is the drop of the potential difference due to internal resistance? What is the potential difference created due to internal resistance? IR. This is the drop of potential difference, means actually potential difference equal to EMF, but due to the internal resistance some drop will occurs, that we have to subtract, then we will get the net voltage as E minus IR. For example, here actual voltage is for example 1.5 volts, but due to internal resistance some voltage drop will occurs, for example 0.2 volt, then the terminal voltage outside the you will get voltage only E minus IR. That means you will get only 1.3 volts. What is 0.2 volts? 0.2 volt is the loss of voltage. Why this loss of voltage or potential difference occurs? Because of internal resistance. that is called as last voltage. Okay, decrease in voltage. Why the decrease in voltage occurs? Due to the internal resistance. And now internal resistance means what? Resistance offered by the electrolyte of cell is called as internal resistance. In the closed circuit, the terminal voltage formulas these are. In the open circuit, the terminal voltage is equal to EMF. And the next relation between terminal voltage comma EMF and internal resistance. Okay, that is nothing but relation between V E R, okay, and I also we will write. Okay, there are several relations I will tell, right? And for that, let us see. It was very simple to derive. For example, this is one cell. Its EMF is epsilon and its internal resistance is small r, and it is connected to some external resistance, okay, capital R. Some current will flow at here, that is I. Now I want the terminal voltage is the potential difference across these 2 points. Okay, this is A and this is B, right? Potential difference, then that is equal to what? And for that, in the closed circuit, okay, here cell discharges the current from the cell, the current supplied. Now the terminal voltage, we write formulas. Terminal voltage formula we write as one formula, potential difference across the cell, current into resistance. Okay, potential difference across this and across this same, because this is parallel combination. In parallel combination, potential difference across the cell equal to potential difference across the resistance. That's why this we write as V is equal to IR. Potential difference across the cell is equal to potential difference across the resistance. In parallel combination, it is same. Potential difference across the resistance is current into resistance. V is equal to IR. This is capital R is the load resistance, or it is also said to be external resistance. Okay, external resistance. Okay, and now let us see, and one more formula we write for the terminal voltage in terms of EMF. Terminal voltage is equal to V is equal to E minus IR. Okay, you must remember the EMF. Many times I am telling EMF is not denoted with capital E. In some books it may be denoted with capital E, there is no problem, but you may confuse with the electric field intensity. That's why I am denoting with epsilon. Okay, and that also you can read as E only. V is equal to E minus IR. V is equal to E minus IR. How I am writing, like that you can write, and also if you have the doubt, you can refer the NCERT book. Okay, V is equal to E minus IR. What is E in this? EMF of cell. What is I? Current. What is small r? Internal resistance of cell. Internal resistance of cell. And now from equation 1 and 2 we write one thing. What we write from equation 1 and 2? Left sides are same, right sides also is same. IR is equal to, we write E minus IR we write. This IR taken to left side. Then IR plus I small r is equal to EMF. Then from this I is common, capital R plus small r is equal to EMF we will get. Then I formula we will get. What you will get? I formula? Tell me from that equation, I is equal to what you will get? Current in the circuit. I is equal to, we will get as this is equation 3. Here we are getting the current formula as I is equal to E by what? Capital R plus small r. This we can write as current in this circuit. If you see the current formula, we got as EMF by total resistance. This capital R and small r are in series, right? Because the current does not divide, same current flows through capital R and small r. It is a one way, only one way, right? Then this formula we write as E is the effective EMF. Current one formula, this is very important formula, effective EMF by effective resistance. Effective means what? Total resistance. Then the current formula in the circuit, we can also write effective EMF by effective resistance. Okay, effective EMF by effective resistance. Then how to find out the internal resistance of the cell when you know EMF and terminal voltage? Okay, now internal resistance formula for internal resistance in terms of EMF and terminal voltage. That formula I am going to write. Then how we will write that formula? Okay. Now in this, what I will do, from equation 1, what we know, V is equal to IR we know, right? And from this we write as I is equal to V by R. I is equal to V by R we write. And now from equation 2 we have V is equal to E minus IR, right? And now in this we write substitute. Okay, I is equal to V by R, we substitute in equation 2 directly. Okay, I is substituted in equation 2. What you will get? V is equal to E minus I is V by R into V is equal to E minus IR. R. I want to find out the small r, right? Then V we will take this V by capital R into small r to left side and this to right side. Okay, this to left side and this to right side. Then we will get E minus V. I want the small r formula. Okay, E minus V by V into capital R. This is the formula for the internal resistance. Okay, and this we can also write as E by V minus 1 into capital R. Okay, and this is equation 5. And one more point I will tell, that is one note point, important point I am going to tell. Okay, note what I am going to tell. Remember, this is important. Important point. Cell may be discharged, cell may be charged, right? If cell discharges means it supplies the current, right? Supplies current. For example, chargeable cells also there, chargeable batteries also there. To charge a battery, we will supply the current to the battery. After that, we will use that battery. While using that battery, the battery supplies the current. Battery supplies the current means that is, cell is supplying the current means that is discharging. Then to charge a cell, we are supplying the current to the cell, that is charging. There is cell may be charged, discharge. Okay, cell battery. Cell means just like battery. Combination of cells is a battery. You take the cell phone cell. Okay, mobile cell, mobile battery. Mobile battery discharges and charges. Discharges means it supplies the current. Charges means it takes the current, right? And now if cell discharges, this is the cell, its EMF is E, and discharges means from the positive terminal current will starts, it will goes outside. This is discharges, right? Now the discharges. If the cell discharges in this moment, what is the terminal voltage? Potential difference across the terminals of cell. Okay, in this case the terminal voltage V is equal to be write as E minus IR. Okay, E minus IR. In this case the terminal voltage less than the EMF, you will get the less EMF. The second case is that cell may be discharged. Charge. If cell charges by external supply, okay, we are charging a cell, we are supplying the current to the cell, right? It happens. This is a cell, right? And here this is a positive terminal and this is a negative terminal and this is the internal resistance. Generally what should happen? The current should be supplied. Current starts from positive terminal of battery, but we are giving the current to the cell. We are giving the current to the cell, right? Look at here. Like this it happened. In this case, what is the terminal voltage, right? Now the voltage, it is charging means across this voltage is increases. Discharging means voltage is decreases. When cell discharges, internal resistance will increases with the time. This term is increase means voltage across the cell is decreases. After few days, when you will use the torchlight cell or wall clock cell continuously, after few days, it cannot work. Why? Because the voltage supplied by it is becomes zero. Why? Because with the time internal resistance increases, this term increases, that's why the voltage decreases. When the voltage nearly it will become zero, then it cannot work. That is the cell not work, cell discharged, it does not supply any voltage, it does not supply any potential. But while charging, the voltage is increases again, right? Voltage is increases means now its formula we will get V equal to E plus IR while charging. Okay, in this case the terminal voltage is greater than EMF, we will get terminal voltage greater than EMF. These formulas we will use when cell discharges. This formula we have to use when cell charges, we have to use this formula. Let us discuss one problem based on this. Okay, look at here, this is our problem and I am going to explain this problem. A battery of EMF 10 volts, this is a battery, its EMF is 10 volts and its internal resistance is 3 ohm. The battery inside some resistance is there, that is 3 ohm, is connected to a resistor. If the current through this battery with internal resistance 3 ohm and EMF 10 volts, it is connected to some resistance or some resistor, its resistance is capital R. If the current through the circuit, through this current is flows, that is 0.5 amperes. What is the resistance of the resistor? This resistance we have to find out, capital R we have to find out, and also find out the terminal voltage. We have to find out the terminal voltage across the cell, that we have to find out. Okay, it was very simple problem. Okay, and the first one is we can use the current formula, right? Effective EMF by effective resistance, capital effective EMF is E, effective resistance is capital R plus small r, right? This formula we have to use, we can find out the R. What is I at here? 0.5 is equal to E is 10 by capital R plus small r is 3, right? And this we can write as 0.5, we write as 1 by 2. 1 by 2 is equal to 10 by capital R plus 3 and cross multiplication, capital R plus 3 is equal to 20. Then R is equal to, we got as 17 ohm. It was very simple. The second question they are asking the terminal voltage. What is the formula for the terminal voltage? Here the terminal voltage we can use either V is equal to IR or V is equal to E minus IR. Anyone you can use. V is equal to IR is a simple formula, right? I we know already 0.5. Capital R is also we know 17, right? 17, 0.5 is nothing but 1 by 2 into 17, that is 17 by 2. 2 adds 16, 2 adds 16 and 2 5 ja, right? 8.5 voltage, 8.5 volts. This is the solution. It was very simple, right? And let us go for the next one homework problem I am giving, that you must answer for this question, and you write your answer in the comment what they gave in the question. And when a current drawn from a battery is 0.5 ampere, its terminal voltage is 20 volts. Here we are drawing the how much current? 0.5 ampere from the battery. Okay, then the terminal voltage is 20 volts. When the current drawn is 2 amperes, when the current drawn changes to other value, when the current drawn from the battery, current extracted from the battery is 2 amperes, then the terminal voltage is 16 volts. Then what is the EMF of the battery and what is the internal resistance of the battery? For this you have to use the formula V is equal to, now the battery is discharging, then at that moment terminal voltage formula is what? E minus IR. Okay, E minus IR. First, but terminal voltage is 20. EMF of cell does not changes, but terminal voltage changes, because EMF of every cell has certain EMF, it does not changes. But here the terminal voltage is initially 20 volts, V is 20, and next EMF is E, current, initial current is 0.5 into small r, one equation you will get. And then after that current changed to 2 amperes and terminal voltage to 16 volts. Once again we substitute Vi is 16 is equal to, and then EMF is E minus current is 2 into smaller, two equations you will get. First V1 equal to E minus I1R, then V2 is equal to E minus I2R. Why we cannot write E1 R1? Because only one cell, the same cell we are using. One time we are extracting the current 0.5, other time we are extracting the current 2 amperes. Why we will extract different currents like this? If you, for example, if you connect the less resistance, it will extract the less current from the more current from the battery. If you give the more resistance here, then more resistance means less current flows. Like this, based on the external resistance, the current extracted will be changes. Then that's why here we write V1 equal to E1 minus I1R, V2 is equal to E2 minus I2R. When current changes, automatically voltage will changes. But EMF, internal resistance, does not changes. The question is that EMF is how much, internal resistance is how much. Firstly, we are drawing the current 0.5, at that moment terminal voltage is 20 volts. Nextly we are drawing the current 2 amperes, at that moment terminal voltage is 16 volts. Then our question EMF is how much and internal resistance is how much. Okay, take the screenshot, and you must I gave the hint also. I am expecting the answer. Okay, the answer you should write in the comment. You must write in YouTube comment this answer. Okay, thank you for listening my classes. Share my lectures to your friends. Subscribe my channel. Thank you.